Hello, students. This is another video that it's going to be complementary to what, or supplementary to what I previous lecture. I know for a fact that this is a very rigorous section, especially if they ask you to do it the way they've been asking students. So hopefully this video serves with great purpose to educate those students and just appreciate the shortcuts that I provide eventually. So for those of you using Carnegie, this is one of the monstrous cases that we have so far. I'm a little spooked that they decided to go this route, but I mean, hopefully with a little explanation, I'll uh, I'll be able to get you guys ongoing. So basically, 5.2, it is area of triangles, but it's not very typical. They give you these slanted triangles on the coordinate grid, and because they're slanted, um, all the segments or all the sides of the triangle are diagonal. So being diagonal is that they have slope. Um, so in this case, we already know that the area of a triangle is a formula that in this case the formula that gives it to us is the base times side divided by two. It's just one of the many forms that we use, and this is the one I stick with because I kind of identify with it since I taught algebra two. So I like rational equations a lot more than the other forms that they presented it. So anyway, as far as a base, you can choose any side to be your base. It's just you choose the one that's more convenient. So in this case, we have the smallest one, which is the one. But just keep that in mind. Any side can be used as the base. So just choose a side for step one. So step one will be, well, in this case, I want to go for PR. Once you choose PR, you gotta choose any point from P to R or anything between it. Um, it could even be P and R. I'd rather just go for the smallest one because I mean it makes the math a lot easier. So in this case, PR, I'm gonna choose point P, which is 3 and 0. All right. So P and 0, I mean 3 and 0, that's my P. That's the point I'm gonna use because I do need it for one of the next steps. So now step three is find slope. Find the slope of your base. In this case, my slope is going to be, well, rise over run, or unless you want to use the slope formula. But if you go up 1, 2, 3, 4, that's 4 up. So my slope for PR is going to be 4. And 1, 2, 3, that's 4/3. And it is a positive segment. So I'll leave it like that. Right now, we'll go back to this guy because we are going to have to calculate the measurement to find the distance. All right. Now, for the height, for the height, all we know about the height so far is that if you have a height from the third vertex or point of the triangle, in this case we have Q, we're gonna have to make a perpendicular side. It's not coming up as great as I thought to, so let me just use this one. So once you go to the from that third point to the base, it doesn't necessarily mean that it's going to be on the middle. It's the perpendicular bisector, like they call it. But it does bisect it, and it does make a 90-degree angle. It's perpendicular. So that's your height. We don't know how much it is or how much exactly it's going to be because we need to find what is this point right here. So this point, we can call it anything from A all the way to Z, with the exception of the three letters that we're using already. So in this case, let's say from Q to, let's say, Q to S or O, right? So the perpendicular height, it's going to be segment PS. And we need to find point S, which is an order pair of XY. We need to figure out where it's located because in order to figure out what the base is, we need that point. Now, the reason also we need it is if you're going to use the Pythagorean theorem to determine the distance from Q to S in this case, you need to know where exactly it is, or otherwise it's going to be an approximate. And that's something that we want to avoid in geometry as much as possible. But in this case, let's go ahead and do the what we're supposed to do. So from PS, we're gonna use point P because we know only. I mean point P. I don't know why I use P. It's supposed to be Q. Okay. So from Q to S, uh, we know only point Q. We don't know any point within the segment or even where S is at the very least. So in this case, we're gonna use point Q, which is 0 and 8. And we're going to go ahead and determine the slope. Well, it's perpendicular height, and I already know the slope of the perpendicular segment. It perpendicular when it intersects. We have 4/3. So when we get the negative reciprocal of 4/3, the slope for Q to S, it's going to be a negative 3/4. Because remember that it has to be a negative reciprocal, so meaning the fraction flips, and it's the opposite integer. So from positive, it goes to negative. So now, what do we do now? So now what we're going to do, and this is where it's very vital to have a graphing calculator because, or just a calculator, but we're going to have to use the y equals y sub 0 is equal to m x minus x sub 0. We're going to have to set up two equations according to the information I already have. So for the first equation, I'm going to set up as y, and because I have point P, y minus 0, 4/3, and x minus 3. So that's my first equation. My second equation, I'll write in blue using the information I got from the height. So I'm going to write y minus 0. Oh, sorry. Y minus 8. It's equal to negative 3/4 x minus 0. So these are my two equations, and this is what we call a system of equations because we need to solve for point S. We need to determine where this coordinate is located. When we solve for x and y, that intersection point that's S is the point that I'm missing, so I can determine the distance. In this case, it's a very nasty fraction because it does happen a lot for these irregular triangles. All we can do now is just play around with it. Thankfully, you don't have to do the method I'm about to show you, but if you must know, you can just type this on the graphing calculator and you will get the coordinate. But because I want to show the algebraic steps, that's my job. So I'm going to get, for the first equation, I'm going to simplify because y minus 0 is just y. And then 4/3 times x and times the negative 3, I'm going to get 4/3 of x. And then 4/3 times negative 3, well, the 3's technically go bye-bye. So this will give me a negative 4. But technically what happens is that 4 times 3, that's 12, and 12 divided by 3, that's going to give you 4. But I mean, that's something that they kind of avoid to tell you. And then because it's positive times negative, it is a negative. Now for the other one, when you simplify it, negative 3/4 times the x and then times the 0, you're going to get y minus 8, and that's equal to negative 3/4 of x. And if you want to move the negative 8, that's fine, but it's not always the best thing. So this is what we have so far. And what's going to happen now is that this y, which is the yellow one there, is the same thing as this y over here, right? So you can either plug in the 4x, the 4/3 of x minus 4 into this y, or you can solve for the y, which is the blue one on the right. You can move by negative 8, moving the negative to the other side, and you can plug in that to the other y. But I mean, don't give yourself more work. Don't do more work for the same amount of pay. I mean, that's my philosophy. So in this case, I'm just gonna go ahead and plug in the 4/3 into this y. So when I plug in that, I'm gonna get, and you don't need parentheses because there's something multiplied. So 4/3 of x minus 4 minus 8, it's equal to negative 3/4 of x. So when you do this, you're going to get 4/3. Negative 4 minus 8, that's negative 12. It's equal to negative 3/4 of x. In this case, we're solving for x, for the x value of the coordinate. So in this case, since the x's are on the right side, it'll be much more feasible to send this to the right. And then we're gonna go ahead and subtract the 4/3 of x. And for those students that have problems with the elementary mathematics here, I'm just gonna show you the steps as much as I can. So I'm gonna get negative 12. It's equal to negative 3/4. And then since they're like terms, I'm gonna subtract the 4/3 and put in parentheses and just put the x outside because I mean they're like terms, right? You don't have to do it like that, but if you want to do negative 3/4 x minus 4/3 of x, I mean, go ahead. So what do we do here? So let me just write a sign note. So the sign note is that I have the 3/4 and they're both negative. So I mean, I'll just write it as positive. And then 4/3. Here's the trick to it. The denominators multiply, so that's gonna multiply. So your denominator is gonna be 12. But what about your numerators? Well, the 3 multiplies the 3 on the left, so that's gonna give you a 9. And the 4 multiplies the 4 on the right, so that's gonna give you 16. So your fraction is gonna be 25 over 12. And since they're both negative, I'm going to get negative 12. It's equal to negative 25 over 12x. Greatest method, right? um, so now what's going to happen is following the order of operations, that division of 12, you can get rid of it by multiplying it on both sides. And then that 25, which is a negative 25, or if you want to do negative 12, that's fine. You're going to divide it uh, by the 25 and just make the whole thing negative. So you know that this guy and this guy are going to get eliminated. So what you do to one side, you do it to the other side. So my fraction for the value of x is going to be negative 144 divided by 25, right? Because remember that the denominator is being divided by 1. And that's going to be my x coordinate. Now, if you want to simplify, I mean, you can just type it on the calculator, just reduce it. So there we have it. Our x coordinate for s, it's going to be 144 negative over 25. Oh, and by the way, it should be positive. So, because remember, it's a negative times the negative. I don't know why I put another 12 there. There you go. That looks a little better. So that should be positive because it's a negative times the negative. I have no idea why I put the other 12 there. Then, anyway, now since we have this x value, we still need the y value of that coordinate. And where do I see a y? Where I mean, an x. It's right here, and it's already y equals format. So what I'm going to do now is I'm going to bounce this x value over here, which just conveniently, when you do this, you're going to get 4/3 times 144 over 25. And this will give you y is equivalent to, well, I know that 3 times 75, 25, that's 75. And I know that 4 times 144, that's a pretty big number, but I believe that's 596. But let me just double check because I don't want to make any more mistakes, right? So if you open up a calculator, and you go to decimals here, and get rid of this. So 4 times 144, well, no, it's 576, right? And I'm the math teacher. So there you go. 576 minus 4, right? And that is reducible, I believe. So if you go to decimals, and in case you don't know how to reduce on decimals, right? I mean, you can just do 576 divided by 75. If you click the circle on the left, it will reduce it. Not that it matters because you're still subtracting by 4, and it gives you the fraction for it. So your y coordinate, it's 92 over 25, if I'm not mistaken. Let me just check that again. Yeah, 92 over 25. And there you go. So that is the coordinate that we were looking for, right? Um, and again, if this is too much work, if this is too much work at any point, I do believe it is. I will give you some grace though, and just tell you right now that if you can get it up to here, you don't have to do all that work that you see. So using a graphing calculator, in this case decimals, because I don't know why anyone wants to use the TI-84 anymore. I'm gonna go ahead and just plug these two in the way I just left them. So I'm gonna plug in the y minus 0, and you can even do it simplified, that's fine. 4/3 x minus 3. Oops. You have to press the right key. X minus 3. Go to the second row. Gotta type in the second equation, y minus 8. It's equal to negative 3/4 of x minus 0. The only problem with this method is if you do it in this method, it will only give it to you in decimals, and then like if you have like an irregular fraction where it gives you all those digits, like let's say like 2/7, right? It will not give you a pretty decimal, and those are gonna have to be approximate, right? Because I don't think decimals will be able to get it out in a form. But anyway, so if you type in these decimals over here, so 5 point, oops, so the 5.76, that is a 5.76, let's see, that is your x coordinate. And if you type the other one, the 3.68, that is your y coordinate, as you can see right here. All right, and I'll make sure I'll add this to the notes so y'all can have as a reference. Because I know it's kind of hard to follow at times. So let me just do you guys that solid. So they are long problems, so you don't have to do all the work I showed you just now just to get your coordinate. You are more than welcome to do this. Just be advised that if you decide to go this route, it is a very demanding part where you do need to be careful what you type. You do have to be careful what you are setting up, because any misstep, it can lead to dramatic a very dramatic answer that you may not want to play with. But as long as you do everything correctly, you should be fine. Okay. All right. So now we have our coordinates. We do have a coordinates. Um, we can use the Pythagorean theorem for sure to figure out the the distance for PR, or the measurement for length of PR. So if we do the Pythagorean theorem, 1, 2, 3, that's 3, 1, 2, 3, 4, right? We can get the measurement for PR by doing 3 squared plus 4 squared, which if you just type it on decimals, it'll give it to you, but I'm just gonna do the math for this one. So 9 plus 16, and we know that's 25, and we know for sure that a radical of 25, it's 5 units. The problem now is Q to S. because we have a fractions, right? So when you set it up, it's going to be 0 minus 144 over 25, or the 5.6, which is okay if you want to do that, plus the 8 minus the 92 over 25, or the 3.68, right? And this is from the distance formula, not the Pythagorean theorem, but I mean, so what can we do here in case we don't know what the decimal is? Again, just go to decimals. Right? I'll be able to do it, but just go to decimals and just use the square root that you have there. So the square root of 0 minus 144.25 plus 8 minus 92 over 25. So it's going to be 7.2. So this will be 7.2 units. So there we have it. So remember that this is your base. This is your height. So because you have that information now you can get the area for PQR, which is going to be base times size. So the base is 5 units times 7.2 units divided by 2. And if you do this successfully through decimals, 5.2 times 5 times 7.2 divided. Just click divide first. You will get 18 units. Sorry, 18 square units. And that's how you get the area of a triangle that's slanted. It is a very rigorous procedure, and I do understand if this is one of those things that you don't want to do because it's a lot of work with a system of equations. You don't have to do it like this, right? You can just graph it on decimals and you get your answer and you move on. And sometimes that's for the best, but we it's a free for all. You choose your method. Now, if you look at the triangles at the bottom here, if you look at the one on the left and compare to the one on the right, the one on the left, you don't have to do the system of equation because since you have a horizontal segment between the, I guess they're using O for whatever reason, but between O to Q, you don't need it in this case. But in this case, on the right, you do need it. But anyway, hopefully you guys like the video. Have a great one.